Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing the topic of number sets. In this question, we're told you may use the Venn diagram to help you answer part A. We are given a universal set, so this symbol here denotes what we call the universal set. And this is the total number of elements in the entire set, so within the rectangle. And the universal set here goes from 1 to 12. You can write them down quickly. X is an integer, so we cannot use any decimals. So the elements here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the elements in this problem. In set M, we have all the possible odd numbers. So we pass by each number in the universal set and we pick the odd numbers. These would be 1, 3, 5, 7, and 9, and 11 as well. So we can write these down next to the odd numbers. 1, 3, 5, 7, 9, and 11. And then for set N, we have the multiples of 3. So we have 3, 6, 9, and 12. And we are required to find the number of values or elements within set N in I. So we just have to count the number of elements in set N. We have 4 elements here. So the answer to I would just simply be 4. Next, we are required to write down the set M intersects N. So M intersects N means we want the common elements between M and N. If I were you, I would just start with the smaller set, which is set N, and I would look at each element and check if it's also in set M or not. So if I look at 3, 3 is in set M, so 3 would work. If I look at 6, 6 is not in set M, so 6 would not work. 9 is in set M, so 9 would work, and 12 is not in set M, so it does not work. So the common elements are 3 and 9. I don't need to check the elements in set M, the other elements in set M, because I've already passed through all the elements in N to check which elements are common between both. And the answer here would simply be curly brackets 3, 9. This is the set M intersects N. In triple I, we're required to write down a set P, where P is a subset of M. So you just need to take any numbers that are in M, not all of them, but just any of them, and that would be a correct answer. So for example, here I can just take the first 3 elements, 1, 3, and 5. This is a valid set that is a subset of set M. So this symbol here means subset, and it means that you pick some of the elements of set M and you write them down as set P. So these are the correct answers here. Here we're given another universal set from 2 to 16. M is the set of even numbers, P is the set of prime numbers. So let's list down the elements of M and the elements of P. You can list all the total elements here, but it might be a waste of time. If you can do this mentally, that would be better. So even numbers would be 2, 4, 6, 8, 10, 12, 14, and 16. These are the even numbers. And then P is the set of prime numbers. So 1 is not a prime number, you should know that. 2 is a prime number, 3 is a prime number. 4 is not a prime number because it's divisible by 2. Now we have 5. We cannot use 6. We can use 7. We cannot use 8 because 8 is divisible by 2. We cannot use 9 because it's divisible by 3. 10 is divisible by 2. Any number that is divisible by any other number is not prime. 11 would be a prime number, 13 would be a prime number, and that's it for the set. 14, 15, and 16 are definitely not prime numbers. So we want the number of elements in M, so we can just count the number of elements that we have in M. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 elements in M, so the answer here is 8. Write down the set P union M complement. So let's first write down P union M. So P union M would be all the elements in M and all the elements in P. So 2, 3, 4, 5, 6, 7, 8, and then 10, 11, 12, 13, 14, and 16. These are the elements in set P union M. And they are basically the combination of everything in M and everything in P, but without repeating any element, of course, more than once. Now, P union M complement is every element that is outside of the set that we wrote down. But it has to lie within the universal set. So the universal set here is from 2 to 16. If you want to write the numbers down, you can. If you want to just visualize it, you can do that as well. So you have all numbers from 2 to 16, and you want all the numbers that are outside of the set P union M. So 2 is there, 3, 4, 5, 6, 7, 8, they are all there. We are missing 9. And then we have 10, 11, 12, 13, 14, and we are missing 15. So the answer is 9 and 15. This is why I meant to write down all the elements here in order, so that it becomes easy to spot the numbers that are missing from the set. So the answer to I is 8, and the answer to double I is 9 and 15. In this question, we are given the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A is the set of X such that X is an odd number. So it's the set of all odd numbers. You can write them down very quickly. So we have 1, 3, 5, 7, and 9. Set B is all square numbers. So that would be 1 and 4 and 9. And then set C is a multiple of 3. So this would be 3 and 6 and 9. And now we are required to write everything down in the Venn diagram. So of course, when you're filling a Venn diagram, you have to start from the overlapping areas. And first you need to start with the number that appeared in all the sets. So we have 9 in all the sets. So you put 9 in the area that is common to all 3 sets, which is this area here. Now, having finished 9, we move on to numbers that are common to 2 sets. So for example, we have 1 and 1, common to set A and B. So we can put 1 in the intersection between A and B. Now 3 is in A and also in C. Remember, this is A, this is B, and this is C. So we have 3 in A and C. So we can put 3 between A and C like this. Now 5 only exists in A. So you can just put it here. And then 7 only exists in A. So you can put that here as well. And now 4 exists in B. So you can put 4 right there. And finally, 6 exists only in C. And you can put the 6 in the region that is exclusive to C. In double I, we are told another number is included in the set, in the universal set, This number is in the region A complement intersects B intersects C. Write down a possible value for this number. So A complement means everything outside of A. So let's just color A like this. Everything outside the green circle, but it is also in the intersection of B and C. So this number has to be common between B and C. So it has to be somewhere here, but it has to be outside of A. So it cannot be an odd number. So we are looking for a number that is a multiple of 3 and also a square number. And we want to find a possible value for this number because it has to be part of B, which means it has to be a square number, and it has to be part of C, which means it has to be a multiple of 3. So try to think of this in terms of prime factors. For example, we know that this number is a multiple of 3, so it's 3 times something. We also know that this number is a square number, so it has to have another 3. In order to be a successful square number, it has to have another 3. Now, we also need this number to be an even number because it has to be outside of A, and A is the set of odd numbers. So since it's A complement, so it has to be an even number. So it has to have a factor that is even. So for example, let's just multiply here by 2. And again, because this is a square number, we have to make sure that we have doubles of every number we have. We cannot have one number that exists only once. So we have to multiply by another 2. This number would satisfy all the conditions. Let's calculate this number. So 3 times 3 is 9. 2 times 2 is 4. 9 times 4 is 36. So 36 would be a good number to place here. And it does satisfy the requirement of B. It is a square number. 36 is 6 times 6. So it is a square number. It satisfies the requirement of C because 36 is 3 times 12. So it's a multiple of 3. And it is not an odd number, it's an even number. So it satisfies the requirement of being in A complement, being outside of A. So 36 is a good number to put for double I. So we seem to have obtained the correct answers here. However, I made a small mistake, so let's go back. So my mistake was that I put in all the elements of A and B and C, but I forgot to list the elements that are in the universal set itself. So the universal set here has elements that we did not account, which are the 2 and the 8. So we should have placed the 2 and the 8 outside of all the sets, but within the rectangular box, of course. So, of course, this here is not relevant, but we have to have 2 and 8 inside the rectangular box. So now we have the correct answer. Here we have another universal set, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. A is the set of multiples of 3, B is the set of prime numbers, and C is the set of x is less than or equal 25. Let's write down the elements of each set. So for multiples of 3, 21 is a multiple of 3. It's 3 times 7. 24 is a multiple of 3. 27 is a multiple of 3. And 30 is a multiple of 3 as well. B is the set of prime numbers. So any even number is not prime, of course. So 22, 24, 26, 28, and 30, these are not prime numbers. Any multiple of 3, of course, is also not a prime number because it's divisible by 3. any multiple of 5 would not be a prime number as well. So 25 is out. So we are left with 23 and 29. These are the prime numbers here. You should have also checked if it's a multiple of 7 or of 11 or of 13, but 23 and 29 are not divisible by any of these numbers, so we can write them down as prime numbers. So 23 and 29 would work here as prime numbers. Finally, in set C, we want x to be less than or equal 25, so we're just going to write 21, 22, 23, 24, and 25. These are the elements of set C. Now we want to plug them into the Venn diagram. So let's first look at the numbers that were repeated across different sets. We have 21, it was repeated in A, and it was repeated in C as well. So 21 lies between A and C, but not in B. So we just put 21 here. 24 seems to be exclusive to A, so we can just put it here. 27 seems to be exclusive to A as well, so we can just put it here. 30 seems to be exclusive to A as well, so we can just put it right there. And then we move on to B. We have 23, which lies between B and C, so we can put 23 right there. And then we have 29, which is exclusive to B. Finally, we look at the elements in C. We have 22, 24, and 25, and these would just be written down. 22 and 25 would be written down here, but 24, I just did not spot this when I was looking. So 24 is repeated across A and C. So we can just remove it from here, and we can put it between A and C, so 21 and 24. Let me just erase this and rewrite it in smaller handwriting. 21 and 24 are both correct answers here. And this completes all the elements of sets A, B, and C. But let's also look to make sure that we did not miss out on any elements. So we have 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 elements here. And in the universal set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 2 elements missing that we need to complete, and we will put them outside of the sets, but inside of the rectangle. So 21 is already there, 22 is already there, 23, 24, 25, but 26 is not there, so we can put 26 outside. And then we have 27, but then we do not have 28, so let's put 28 outside as well. And this completes our Venn diagram. Next, we need to use set notation to complete the statements. So 26 and B, what is the relation between 26 and B? So 26 is an element, it's not a set, it's just a single element. So is it an element of B or not an element of B? It is not an element of B. So this is the correct symbol to use. In double I, we have A intersects B. So we can tell from the Venn diagram that A and B do not have any common numbers. So the answer here would be phi. They do not intersect anywhere. There is no common element between them. In C, we are required to list the elements of B union C intersects A. So let's list B alone and C intersects A alone. And then let's list the union set. So B has been written above. It's just 23 and 29. C intersects A is the common elements between C and A. And from the Venn diagram, this is 21 and 24. So therefore, B union C intersects A would be all the 4 elements, 23, 29, 21, and 24. This would be the correct answer for C. In D, we are required to find the number of elements in C. So if we count the number of elements in C, let's go and count them. We have 1, 2, 3, 4, 5. So we have 5 elements in C. Next, we want the number of elements in B complement union B intersects C. So let's just first evaluate what these sets are. So B intersects C is the common elements between B and C, which is basically 23. And then B complement is everything that is outside of B. So that would be everything except 23 and 29. So we have 21, 22, 23. Excuse me, so we don't have 23 and we don't have 29. So 24, 25, 26, 27, 28. This is B complement. So the union between B complement and B intersects C is basically everything in each one. So we just put in our set 23, and then we put everything in B complement, 21, 22, 24, 25, 26, 27, 28. And then we simply need to count the elements in the set. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 elements in the set. In E, we are told A intersects C is a subset of A union C, and we want to complete this statement using set notation. So all we have to do here is just write A intersects C is a subset of A union C. And these are the answers of the marking scheme. And we seem to have obtained the correct answers for everything. It is only mentioned in E that instead of using subset as a strict subset, like what I did, you can also use subset or equal, but this is a technicality. It's okay if we skip this. We can just use subset, which looks like the letter C here, which tells us that one set belongs to another set. In this question, we're told X is an integer, and we are given the universal set, and A and B and C are 3 other sets. So let's list them down. So the universal set is between 41 and 50. I'm just going to write everything out. So 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. This is the universal set. In set A, X has to be an odd number. So let's just write down the odd numbers here. So 41, 43, 45, 47, 49. This would be set A. And then for set B, X has to be a multiple of 3. Of course, one way to check if a number is a multiple of 3 is to add the digits. So for example, we have 41, so 4 plus 1 is 5. 5 is not divisible by 3. In 42, 4 plus 2 is 6. 6 is divisible by 3, so we can write down 42. Here, 4 plus 3 is 7. That doesn't work. 4 plus 4 is 8. 4 plus 5 is 9, so that works. So 45 would work. 4 plus 6 is 10. 4 plus 7, 11. 4 plus 8 is 12. 12 is divisible by 3. So we can write down 48. And then 4 plus 9 is 13. So that doesn't work. And 5 plus 0 is 5. So that does not work either. So these are the numbers. In C, we are told X is a prime number. So we want a number that is not divisible by 2, of course. So let's just mark the numbers that are out of our scope. So any even number is not a prime number. So these are all not prime numbers. Any number divisible by 3, and we already wrote those down, 42, 45, and 48. Any number not divisible by 5, and we already have that as well. Here we also have a number that is divisible by 7, which is 49. So 49 is divisible by 7. So this is not a prime number either. And we are left with 41, 43, and 47. And these are prime numbers. So 41, 43, and 47 are prime numbers. We want to complete the Venn diagram. So like we said, we take each number and we look for the common numbers across different sets. Remember, this is set B, this is set C. So for example, here we have 41 and here we have 41 as well. So 41 lies between A and C. Now we have 43. 43 is common between A and C again. So let's write this down. 43 here would work. 45 is common between A and B. So 45 would be here. 47 is common between A and C. So let's write it down between A and C. "49 is only existing in A, so let's just write it in A right there. Now we have 42, which only exists in B, and 48, which only exists in B as well. In the Venn diagram, we have 7 numbers, and in the universal set, if we count the numbers, we can just check each number one at a time. So 41 already was written down between A and C. 42 was written in B. 43 was written as well. 44 was not written anywhere. So let's write down 44 outside like this. 45 was written already. 46 was not written anywhere. So let's just write down 46 outside. 47 was written down. 48 was written down. 49 was written down. 50 was not written down anywhere. So let's just write down 50 within the rectangular box like this. In B, we are required to list the elements of A intersects C. So this is simple enough. This would be 47, 41, and 43. And remember to close the curly brackets. In double I, we are required to find B union C complement. So let's first find B union C. So B union C is equal to everything in B. So let's just write down everything in B, which is 42, 45, and 48. And then let's write down everything in C and just avoid repeating any number. So 41, 43, and 47. These are the elements of B union C. So therefore, B union C complement would be all the other elements. So the complement of B union C would be all the other elements. Of course, you can use the Venn diagram to figure this out automatically without listing down the numbers. Here is the quicker way of doing this. So B union C is everything inside this green circle, as well as everything inside this other green circle. So we want all the numbers outside the 2 green circles. So these numbers are 49, 44, 46, and 50. You can just use the Venn diagram to figure this out. In C, we are required to find the number of elements that lie between A and B and C. Of course, we don't have any elements lying between A and B and C because this is the region for the common elements between all three sets, and there are no numbers there. So the number of elements is 0. And we seem to have obtained the correct answers here. Let me just clear the screen. So in this question here, we have the universal set 7, 9.3, pi, 5/9, and 2 radical 8. In A, we want to list all the integers. So the integers here, the only integer here is actually 7. And then the irrational numbers here would be, so integers means just a number without any decimal or fraction. An irrational number is a number that cannot be expressed as a decimal or fraction, as a finite decimal or fraction. So this is rational and this is rational. The only irrational numbers here are pi and 2√8. In general, the only irrational numbers are pi and square roots of all numbers except perfect squares. So √3 is irrational. However, √4 is actually rational because √4 is equal to 2. √5 is same as √3. √7 is same as them as well. But for example, √9 would be a rational number because this is equal to 3. So any root under which you have a perfect square is a rational number. So √4, √9, √25, these are rational. Any other root is an irrational number automatically. So in order to fill in here the Venn diagram, we would write 7 inside of A. We would write pi and 2√8 inside of B. And then we would write the remaining numbers, which are 9.3 and 5/9 outside of the two circles like this. And this would be the solution here. And we seem to have obtained the correct solution. In this question here, we are told C equals X such that X is an integer and 5 is less than X less than 12. D is 5 and 10. Put a ring around the correct statement. So let's first expand this set here. So it's going to be 6, 7, 8, 9, 10, and 11. So the common number or element between the two sets here, of course, is 10. So therefore, the correct statement is C intersects D equals 10. Now we want to find the number of elements in C union D. So let's list down C. So we have 6, 7, 8, 9, 10, 11. And then let's list all of D. We have 5 and 10, but we will not write 10 because we already wrote it down and we will not repeat any elements. So now we have our set, which is C union D. And we want the number of elements here. So you can just count the numbers and you will find that they are equal to 7 in total. In this question here, we are told that the universal set is X such that X is an integer and 1 is less than X and X is less than 10. So X lies between 1 and 10. Let's quickly list down all the possible numbers here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now for A, we want to write down the even numbers. We have 2, 4, 6, 8, 10. One nice idea, since this is rough work, and what we're doing here is just rough work in preparation for the answer. So you're allowed to do anything you want with your work, of course. So you can just cancel out any number that you've already written down. So the 2 and 4 and 6 and 8 and 10, you can just cross them out like this very briefly, so that when you're trying to figure out which numbers to put inside the rectangle but outside of the circles, it's just easier to figure them out. Now, we're told that 4 belongs to A intersects B. So the 4 should be listed in here. And we're told that the number of elements in A intersects B is 1. So we just know that there is only one element, which we know. We already know that this is 4. So there is no other element between A and B. Finally, we are told that A union B complement is 1, 7, and 9. So these elements exist outside of A union B. So A union B is basically everything inside the two blue circles. And then everything outside is the complement. So 1, 7, and 9 must be written outside like this. And then we can cross these out as well. And then the remaining numbers, the only remaining numbers here are 3 and 5. So these must belong to set B. So we must put 3 and 5 in here like this. And they want us to complete the statement. So the elements in B are 3 and 4 and 5. And this seems to be the correct answer here. Of course, I just forgot to list the elements of A. These elements, I just forgot to put them in the Venn diagram, excuse me. So let's just put them in here very quickly. So we have 2, 4, 6, 8, 10. 2, and we already have the 4 here. Then we have to put 6 and 8 and 10. And now we have the correct Venn diagram. As for double I, we got the correct answer, which is 3 and 4 and 5. Here we are told m equals x, such that x is an integer and 2 is less than or equal x, which is less than 6. Find the number of elements in m. So this is 2, 3, 4, 5. And the number of elements here is 4. In double I, we want to write down a set n, where n is a subset of m. So we can simply choose any of the elements, but not all of them. So we can just write 2 and 3, for example, and this would work as a subset. So 4 and 2, 3 would be a correct answer here. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.